Okay. Oh, I got my mask shirt on. Okay. Anyway. Okay, you guys should be doing your those first four questions. Oh, forget it. If you don't know at this point, you're doomed. Oh, and by the way, hey, so you lockport this math. I can define these words later. So those are your I can statements. I can. I don't think I'm doing composition, I guess. Um, and then one more thing. I don't like this is specific to this one book, and I'm okay with it. I just have never seen it before, and I'm gonna have troubles with this. But we're gonna change images. So the image before you change it is called the pre-image. I guess that's okay. Then the one when you're done, I'm gonna be saying like post-image or after, the new image, but it's just really called the image, and I don't like that. I'll say new image a lot of times. I really feel like it should be image and then new image, but so it's just a semantic. It's a detail. It's specific to this one author. Not a big deal. Not making fun of them. It's just that. And then I don't know. It was supposed to be bell work. Whatever. Hopefully you remember that a negative in the front's a reflection over the x-axis. Just so you know that we've done these transformations before. -2 is 2 right. +5 is 5 up. That's a parabola. We did a whole chapter on that. 3 in front for letter C is called a dilation. That's what we're going to look at today in a much different way, though. And then you got it all on letter D. Not all, but most. Negative on the outside, reflection over the x-axis. 1/3, shrink by a vertical, I should say, shrink by a factor of 1/3. 5 left, 2 down. So you've done this year, but now it's going to be a little different. This is going to make the notes pretty quick, me giving you a copy. I must not have given a copy last year. Had to spend a lot of downtime with students doing like long drawings and all the writing. Just kind of a waste of time because my video last year was like 30 minutes long. I have no idea how or why. So I got to get rid of that video. Okay, so then on the next part, I'm stalling so they can write that. I don't know. Wasting time. Okay. So how can I do, and this is already done, but just watch my pen because this is what I'm going to do in the next couple. How can I do like dilations through a construction on a piece of paper? All right. We're going to do it by a scale factor of 1/2. So this is what this first method is. And then I'll show you the second method, and then I kind of combine them and make sure they both hold true through all the notes we're going to do today. So here's the first one. Through point P, they want you to do 1/2 scale factor. So one thing I want you to note, since this is already created, the new image, that's called B prime. That's B apostrophe. Is that an apostrophe, right? Correct? Yes? What you doing over there? What you getting out of the bag? All right. Were you on time today? That's good. It's a late start. You got all that extra time. All right. And then C prime and A prime. Okay, now here's what actually happened. From this point P, you draw a segment connecting to B. And then to do 1/2, you go halfway between P and B. And what would be nice is if you have a measuring tool. All right. But what I could do is come up here, if I don't choke myself on this cord, I got this and then shift like that. There goes my headphones. All right. And then that works out. So that looks good. You don't know what happened. I was off screen there. Oh, I should have turned this so you get a double screen effect. Nice. Where is this cord? Okay. And then the same thing. Yeah. You got this line right here, and then you go halfway. And then you got this dotted line, and then you go halfway. All right. And then that's in the middle. And then I draw the new image. That's what I'm going to call it all the time, new image, even though I'm supposed to say image. Okay. So that's what we got there. Big rocket science here. Here's the other way. The other way is to do this. Now you could read up there, and you could read. I'm just going to do it. Okay. This one we're going to double. So what I have to do is draw through W and go double the distance. So I could do this. I think I could reach, I could double check. I got my fingers here, and then I don't move this distance here, and I move here. Yeah, that looks like I did 2 ticks of that distance. And now I draw my new W, which is called W prime. So one new thing today, the notation of new image or image. But then what I do is this. And now I think you should do a combination of these two methods. Draw either right or left a segment that is parallel to its corresponding segment. And then end, oh, I'm sorry. You have to draw this dotted line like quite a distance, and then draw that parallel segment, and then stop when you hit the dotted line. And as long as that line I drew is parallel to WX, then it should be the new image of WX, W prime X prime. And then draw this dotted line through Y and then keep going as long as possible, and then draw a parallel image to XY. And then do the same thing here, through and through. I'm definitely drawing. The pen was not activating. I love you, computer. Parallel, parallel. And then you can also discount double check these distances. Might be tough because this is kind of large, but I'll go from finger to thumb and then slide finger to thumb. That looks about double the distance. So it's a combination of the two rules after you're done should be helpful. So this is how you do a construction, all right, of dilating things. Okay, let's move to the next page so this doesn't take too long. And then I'm going to do one from scratch, meaning I don't see anything. And you could try. I think I'm only going to do one of these because it's, I don't know. On the quiz, we're going to have a quiz a week from this Friday. It's going to be on 5 sections. By the way, does anyone know what unit we're in? Someone last hour got it right away. What unit are we in if we're going in order? Anyone know? 3, 2, not 6, not 7. Not 9. It's 8. But they say chapter 9 in our notes thing, like in our thing, because I'm not changing that this year. Next year, maybe you don't care. I'm going to change the units to what we're actually going in order. But this is the 8th unit. Now, did I say this in the beginning? We just got a hodgepodge bunch of stuff. We just did probability. What the heck are you doing, Mr. Samuelis? That's this class. You're getting like introductory things of all these different subject matters. But I will say this, now it's becoming more streamlined because this is going to be leading to similar triangles. And then from similar triangles, we can develop the concept of trig. Anyone? Trigonometry. Does anyone know this? Nobody knows this? Nice. Does anyone know what sine? There's sine. What's next? Anyone know? Cosine. Good. What's the other one? Tangent. Okay, so this is going to lead into that next. So this idea of dilating, reflecting, translating, many cases you end up with a similar figure, so that's why we kind of start with this. But anyway, dilate by a scale factor of 3. I'm going to do a combination of both methods. 1, do another one, 2, 3. And then I'm going to double check. I kind of went crooked there. And I don't know if I like my distances. I might redo these. No way. I hate that first one. Hate it. He's using the word hate. All right. And maybe like right there is a little bit better. And then maybe like right there is a little bit better. Let me double check my distances. Finger. I like it. I like it a lot. Okay. So this is K prime. And then you know what I'm going to do? I like the parallel method. So what I'm going to do is do this and then check the distances after. I'm going to go parallel to I missed something though. I got to do my dotted line. I was kind of doing that wrong on the other. So I want this to be parallel with KL. And then I could check those distances. Boy, it looks like I'm going a little off there. Straight edge would probably be nice. Kind of like curving there. So 1, probably right around there. 2, 3. Let's see how close I am. Oh man, that's awfully large. Kind of, maybe a little bit off there. Doing the best you can. I'm doing the best I can. All right, and then parallel, which is kind of like this. Boom. And then as long as this is parallel to JK, you should feel pretty good about that. J prime L prime. Okay. Then I had trouble. I'm going to be honest. First hour, I forgot how to do the next one. And then I kind of cheated. Okay. So through M, it's a little bit tougher when you have to shrink. So how do I take 1/3 of this? Well, and then I should have figured it out. If I had to do 1/2, all I would do is have to find the halfway marks of all those segments. So 1/3, I have to cut the segments into thirds. So I have to do the best I can in getting in thirds. So I'll check if that works with my fingers. Okay, does that look the same distance as that? It's not too bad. And then actually P prime is that second mark because I cut it 2 iterations of equal markings. Okay, so that's actually going to be 1/3. It's kind of weird, but that's actually what happened. We can prove this when we do a coordinate plane and we can actually count. Then you know what I'm going to do? I'm going to do the parallel method. So here's P prime. My next one should be here, and it should be parallel to PR, and that should be where R prime is. I think I'm close. It's kind of hard to do parallel, especially without a coordinate plane. That's why we're going to a coordinate plane next. Another reason why I like coordinate plane, we get to talk about some things and attributes of a coordinate plane. Approximately parallel there, that's Q prime, and then it goes back to P prime. Kind of, sort of, looks like 1/3 of the other one. Not until we get a coordinate plane can we actually prove it doing the same actions. Although with the coordinate plane, we can do something different. Okay, now go ahead and write this stuff down. Like I said, maybe in the other times I wrote all this stuff out. Ooh, a sneeze is coming on. Oh, I lost it. That is the most frustrating thing. And an already frustrating day of having 3 meetings I didn't want to have and get my mind scrambled and then have to teach 120 teenagers. I love Wednesdays. Okay, I'm just stalling for you to take this stuff down. And then this is Mickey Mouse stuff here. Okay, so what's the scale factor going to be? Greater than 1 or less than 1? Class. 3, 2, 1, go. Oh, no. Which one has the primes on it? The bigger or the smaller? The bigger. So the scale factor is going to be bigger than factor. It's going to be bigger than 1. Okay, and then you're going to find out that it's this is how you're going to do similar figure side relationships. They're proportional. So this side right here, as you're writing stuff down, is 6. This side is 2. How do I get 6 from 2? I multiply it by a factor of 3. You probably already did this stuff in grade school. All right. And then the same thing applied for BA and B prime, A prime. 3 and 9 are those two lengths. So that's what happens there. But not all kidding aside, this is what we're going to get into with triangles. We're going to talk about how triangles are similar, and then you're going to have some postulates and theorems. Do you remember last year, SAS, SSS, ASA? Remember that stuff? That's for triangles being congruent. But there's also some postulates or theorems that prove that two triangles are similar. There is an SAS similarity, there is an SSS similarity, but then there's an AA similarity. Wild. That doesn't happen with triangles being congruent. So what you're going to find out is the sides are proportional. That's what the scale factor comes from. So A prime B prime over AB should equal B prime C prime over BC, and so on and so on and so forth. But what you're also going to find out is that's why there's an AA postulate for similar triangles, because in similar triangles, the angles are still equal. All of those angle measures are 90 degrees. So all those angles are equal. You'll find that out in similar triangles. That's why trigonometry can be done. Any triangle that has, say, like 27 degrees as one of the angles, 90, I don't want to embarrass myself. I think I'm left with 63. 63, 27, 90. any one of those triangles that have those angle measures, the sides would be proportional. And that's what sine, cosine, and trig is based off of. So you can use those to find sides when you're given angles, or angles when you're given sides. It's actually a neat little, I love it. Trig's my favorite thing to teach. So we're going to have some fun coming up. And actually in CAT, I'm in heaven. You can't say that in a public school. Because it's all semester of trig. Except what's not fun is we just took a quiz yesterday and I had students get a 0 out of 50, a 1 out of 50, a 5 out of 50, and then someone knocked it out of the park and got an 11 out of 50. And this is what I deal with those kids. Does anyone see a problem with this? A 0 out of 50 on a quiz? Anyone? Bueller? Okay, anyway, thanks for listening. I think you're all just looking at me like, what should my scale factor be? Bigger than 1 or smaller than 1? Smaller. Okay, and then this is ridiculous. This is like a waste. This is why I did, you know, a printed notes, half a page, or 2 pages per 1 page. But here's now when you're in a coordinate plane, this gets a little bit better. We could see the relationship better. And then it's going to get better than that when we get our next example. So I'll only do one of the, through P, let's do dilation by a factor of, well, what is it? Well, this is 2 and this is 1, 2, 3, 4, 5, 6. So it's 2 over 6 because the new image is smaller, right? So do be careful on that scale factor. It's not 3. The primes are on the smaller figure. But then also I could do this. Look, I don't know if I could. I'm going to slide this over there so I don't choke myself out. Okay, here's my fingers. Look, 1, 2. That was 2 distances. So now that corresponds to the method, of how you break this down into thirds, right? Anyway, same thing happens with x prime and so on and so forth. Okay, and then just go ahead and stamp this down because I felt this was insulting your intelligence at this point. But add one more thing. Mr. Stronowski maybe wanted to take a day of like geometry notation to make sure you know your notations. And that's fine if you wanted to do that, but I think we do it on the fly. So if these are similar, what I decided in this image was to show like what it means to have equal angles and how they could be marked. One way is to do an arc and an arc and put 1 slash. And then that means this needs 2 slashes. This needs 3. Then it gets ugly. That needs 4. Oh, 4 marks is kind of hard to delineate. Or it could be arc, and then this would be 2 arcs and 2 arcs, 3 arcs and 3 arcs. I think you guys could figure this out. I think you've seen this before. Same thing with sides being equal. Mark, 1 mark, 1 mark, 2 mark, 2 marks, 3 marks, 3 marks. So on and so on and so forth. Why is the image greater than 1 scale factor, I mean? Because the bigger image has the primes. So knowing prime means new image, even though I'm supposed to say image. Okay, then I like this. I like this that we could see this. Is this an enlargement or reduction? Which one is it? 3, 2, 1, go. Reduction. And then I could do the fingers on this one. Okay, if I look at this, this is equal to this distance right here. So it did 1 notch down. That's 1/2. It got knocked down by 1/2. Or 2, 4. 2 over 4 equals 1/2. Or the whole thing with my fingers along that dotted line. You can be assured, even though I can't find BC and B prime, C prime, you could use the distance formula. But those would also be by a factor of 1/2. But I don't really have a coordinate plane with coordinates noted, so I'd have to make up something. We did the distance formula this year. Do you remember? Do you remember, Winston? No one else is talking to me. Do you guys remember doing the distance formula in here? It was in conic sections. Okay, now, huh? What? Huh? Okay, so here's specific to this author. this author decided to do transformations through this notation. Big D means dilation. Tomorrow we're going to go through more rotations, reflections. Those are both start with an R. One's a capital R, one's a lowercase r when they put it up in front. It's real wild. Then I forgot some other ones. There's shifts. I forget how the shifts are listed. I don't know what letter they use. We'll figure that out tomorrow. So this means by dilation by a factor of 3. Look at how much better it is in a coordinate plane. Actually, I'm going to do something a little quicker than the other hours that I did in the other hours. When you're in a coordinate plane, it makes it a lot easier. Here's C, which is at 3, 0. You know what? I will write it over here. Here's A. A is the next one. I won't do this. 2, -1. Here's B. Finally, I went alphabetical. First and second hour, I didn't. Nobody cares. Nobody cares. -1, 2. And then C is 3, 0. When you're in a coordinate plane, and that's why I like doing this too, to remind you of a coordinate plane. Like, what quadrant is this over here, everyone? Give me the number. 3, 2, 1, go. 1. What quadrant is this, everyone? 3, 2, 1, go. I tried to trick you. That's 4. Math, counterclockwise seems to be the norm. As a matter of fact, when we get into coordinate plane trigonometry, which is coming up 2 chapters from now, the normal direction when you put a coordinate plane angle, an angle in a coordinate plane, is counterclockwise. Strange. I don't know why it is. I don't know what the reasoning is, but it's true. But take all these coordinates, both x and y, and multiply them by 3. 3 times 2 is 6. 3 times -1 is -3. Watch. Oh, A prime is the worst one. Fine, I'll do it. 2, 3, 4, 5, 6, comma 1, 2, 3. Here's where A prime should approximately end up. And then watch the line from the origin. Sorry, I skipped over that. These are now all dilations about the origin. And it does say so that up there. Okay, watch. Dotted line. Oh, no, I missed the point. I went through the letter A. Give me a second. I don't want to get the eraser. Okay, through the letter A to A prime, and I'm close. Look, here's my fingers from here to here. Yeah. Slide once, slide twice. And now it does look like the very first way that I showed you. That is 2 iterations away from the original. That's 3 times bigger then. If I would have stopped at that second mark, then I would have doubled the image. All right, and then 3 times. So B prime is -3, comma 6. So -3, comma 1, 2, 3, 4, 5, 6. We're up here. All right, and then dot, 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 B prime. And then C is 9. Oh, we're going to be in the way. 9, comma 0. 5, 6. It's like way out here. I'm in the middle. Hold on. Yeehaw. And then we're going to shrink this down. And then we're going to move this over here. And then we're all going to be happy. And then 5, 6, 7, 8, 9. Somewhere around there. You know what else you could check, though? The parallelness of this side compared to this side. The parallelness of this side compared to BC. And then the parallelness of BA. And it's pretty darn close. Are you guys okay over there? Behave, children. I know this seems like a grade school little lesson here, but we should be mature. Okay, now this is -4, 0. You can see I'm losing my audience here. 8, comma 4. Attention to the common housefly span. Anyway, 12, comma -4. Let's just stick those right in there. And then good thing they are all multiples of 4, because to find a dilation by a factor of a fourth, R prime should be -1, 0, 1/4 of -4, then 1/4 of 0, of course. And then P prime, 1/4 of 8 is 2, 1/4 of 4 is 1. And then Q prime is 1/4 of 12, 1/4 of -4, -1, 0, 2, comma 1. I'm not going to mark these because it's kind of 2, 1, 2, 3, comma 1. But what I will do is maybe check from the origin to P, my fingers. Origin to this point, P prime. 1, 2, 3. Three times. So this dot to another dot to another dot, 3 dots. The third dot is where P, the original P comes from. Go 3 backwards, and now you got 1/4 of the size. Kind of weird, right? But that's what happens. And then we'd have to use the distance formula to check that proportionality does hold at 1/4. All right, but I would have to find the distance from P to Q, and then the distance from P prime to Q prime, then divide them, and you'd get a fourth. It would happen, and it should. So coordinate planes work a lot better for this. Okay, hasta la vista, baby.